Hey everybody, I'm going to make another support video for you guys. This one's on solving two-step equations. Alright, so let's go. This one is 7n minus 4 equals 31. So first thing, copy it down obviously. So on your paper you do something like this. 7 times n minus 4 is equal to 31. Okay, so the goal when solving a two-step equation is to get the variable by itself. You start that process by getting the variable term by itself. So you're going to want to get that 7n all by itself, which means we want to undo this minus 4, right? How do we get rid of this minus 4? Well, what would undo is subtraction? Addition, right? So you could just add 4 to both sides. That would work. So that's what you do. You add 4 to not just one side, but to both sides. The rule for solving any equation is that whatever you do to one side, you have to do to the other, right? You gotta maintain that balance. So this is the equals line, right? This is a balanced value on the left and right. They're worth the same. So whatever you do to the left, you have to do to the right. So we're going to show one operation to both sides at a time as we work down. So equation, operation to both sides, equivalent equation. And all that means when I say equivalent equation means an equation that has the same solution. Okay? So now we have negative 4 plus 4, which is 0. So I'm going to show that that's a 0. You're left with 7 n's, and that's equal to 31 plus 4. Well, what is 31 plus 4? That is 35. Okay? Now you wanted to get the value of not 7 n's. You want to get the value of 1 n. So how do we undo times by 7? You divide by 7. So if you divide both sides of your equation by 7, you're going to get the value of 1n. So 7 over 7, 1n is equal to 35 divided by 7, which is 5. So we think the answer is that n equals 5. And we can do a little mental check and see if it works. Is 7 times 5 minus 4 equal to 31? 7 times 5 is 35. 35 minus 4 is in fact 31. So I did a little mental check just to make sure that I didn't make any silly mistakes there. And n is equal to 5. Okay, so you put a 5 in there, it already has the n is equal to. Okay, now let's do the next problem. So let's do the next problem. All right, number 2. Número dos. This time we're having negative 13 is equal to r over 9, and you're adding 8 to that. Okay? So once again, your goal is to get the variable term by itself. How do we get rid of plus 8? You're going to minus 8, not to one side, but to both sides. So I'll draw the little equals line down there for you guys, and let's do this. So minus 8, not to one side, but to both sides. You're going to get a 0 pair here on the right, and you're going to be left with r over 9. So r over 9 is equal to the sum of negative 13 and negative 8. Remember, there's like an imaginary plus sign here, right? You're taking away 8, which is the same as adding a negative 8, right? So this is 8, take away 8, or 8 plus negative 8. This is negative 13 plus negative 8. So negative 13 plus negative 8 is going to get more negative. That's going to become negative what? Well, 13 plus 8, 21. So what you have here is negative 21 is equal to r over 9. Well, now you want to undo that over 9, right? Divided by 9. Fraction is just the top divided by the bottom. So this is like r divided by 9. You want to undo division, so you use multiplication. The way you show this is you multiply both sides by the denominator. In this case, 9. 9 over 9 is going to be 1 because this is the same as 9 over 1. So we have r over 9 times 9 over 1. These are going to cancel out because 9 over 9 is 1, and you end up with r over 1, which is just r. So that's r is equal to. And over here you get 9 times negative 21. A positive times a negative is a negative. 9 times 20 is 180. 9 times 1 is 8, so this is 188. So we think the answer is negative 188. And we can check it if we wanted to. We can say, is negative 188 divided by 9 plus 8 going to be equal to negative 13? And if you did negative 188 divided by 9, you get a negative divided by positive is a negative. 9 goes into 18 twice, so nothing left over. 9 goes into 8 0 times. Did I write? Something I did there is weird. Oh, there you go, guys. I made a silly mistake. I'm glad I checked it because that didn't work, right? And you know why it didn't work? Because 9 times 21 is not 188. 9 times 21 is 9 times 20, which is 180, and 9 times 1, which is 9. So it's going to be 189, silly me. So I made a boo-boo there. So that's negative 189. And now if we check it, it should work. So 189 divided by 9. 9 into 18 goes 2. 9 into 9 goes 1. That's 21. So that would be negative 21. And negative 21 plus 8, is that equal to negative 13? And the answer is yes. Okay. So now we've checked it. We know it's going to work. It's going to be negative 189. And so that's why you check your working algebra, right? When you get the answer, you take it, you plug it back into the original to see if you get a true statement. If it doesn't feel right or you made a little boo-boo, find your error and you're good to go. That's kind of the beauty of algebra. All right, let's do the next problem, number 3. Okay. This one is 42 is equal to negative 7 times the quantity of z minus 3. So you have actually several choices about how you want to go about doing this. But I think the simplest way to do it is to distribute first. So I would distribute first. And once you distribute, then what you're going to do is you're going to look to get the variable term by itself. So what's negative 7 times z? That's negative 7z. What's negative 7 times a negative 3? That's a positive 21. So really, this is equivalent to 42 is equal to negative 7z plus 21. Now you want to get the variable term by itself. So how do we get rid of plus 21? We get rid of plus 21 by minusing 21 to both sides. So you're going to get minus 21 to both sides. Minus 21 to both sides. What's 42 plus negative 21? Well, that's going to be 21. So we get 21 is equal to negative 7z. And now you want to get that z by itself, so that 1z. So how do you undo times by a negative 7? You divide by a negative 7, both sides. So you want negative 7 over negative 7, which is positive 1. That's positive 1z. And that's equal to a 21 divided by a negative 7. Positive divided by negative is negative, and 21 divided by 7 is 3. So that would be a negative 3. So we know that if negative 3 equals z, it must also be true that z must be equal to negative 3. So it doesn't matter which side you have the variable on as long as you understand its value. So the answer is that z is equal to negative 3. Plug it in and check. Is negative 3 minus 3 times negative 7 equal to 42? Well, negative 3 minus 3 is negative 6. Negative 6 times negative 7 is positive 42. So that one's easy to check and it works. So our answer is going to be z is equal to negative 3. When I started, I said you had choices. If you didn't want to distribute that negative 7 first, you could have divided both sides by negative 7. And just so you guys can see an alternate reality if you did that, the alternate reality would be that when you divide this by negative 7, negative 7 over negative 7 is 1. So this would just become z minus 3 on the right side. But then over here you get 42 divided by negative 7, which is going to be a negative 6. And then you could solve this equation. How do you undo minus 3, add 3 to both sides? And ultimately you still get the very same answer, which is of course that z is equal to negative 3. So you could have divided both sides by that factor of negative 7 and then broken the parentheses out that way. It can work either way. Just pick your preference. I like to distribute first and then combine like terms and then get my variable by itself. All right, let's put our answer in. So this is going to be z is equal to negative 3. All right, we're good on that. Let's do the next one. The next one is going to be 2 times the quantity of t plus 1 equals 10. Okay, so that's number 4, I think. Number 4. 2 times the quantity of t plus 1 is equal to 10. Now, like I said, I like to distribute first. So if it was me, I would go like this. I'd say 2 times t plus 2 times 1. That's 2t plus 2 is now equal to 10. And then I would get my variable term by itself. I want to undo plus 2, so I'd minus 2 to both sides because I want to get rid of that plus 2. So as long as you do it to one side and the other exactly the same way, you're maintaining the solution of the equation being the same. So you have equivalent solution, equivalent equation. So anyways, as you go through and do that, you're going to see that this becomes a 0 pair. Let me change to the pen. This becomes a 0 pair. And you're left with 2t now is equal to 8. And then how do you undo times by 2? You would divide both sides by 2, and therefore t is equal to 4. So we think the answer is 4. You can always check it. What's 4 plus 1? 5. 5 times 2, 10. It works. If you wanted to do it the other way, here's your alternate way. Your alternate way would be to divide both sides by 2. So then you get t plus 1 is equal to half of 10, which is what? 5. And then you can solve it. How do you undo plus 1, minus 1 to both sides? This becomes a 0 pair, and so t still equals 4, right? So you can do it either of those ways, whether you distribute first, then combine like terms and get the variable by itself, or you just undo the factor of 2 here by dividing both sides of your equation by 2, and then going from there. Ultimately, like I said, it doesn't matter which you choose as long as you're comfortable. What I do recommend, though, is that you guys make sure you always are thinking carefully about making sure whatever you do to one side, you do to the other. That's your only important rule that you really need to make sure you always follow. And with that in mind, if you have more than just multiplication on one side, in other words, you got several terms or something like that, I think it's cleaner to distribute than combine like terms, because oftentimes when students try to divide first, they make mistakes. Okay? So the answer here was t equals 4. Let's just put that in. Next problem. All right, let's jump in here and do the next one. This is number 5. Number 5 is 41 equals 12d minus 7. Your goal is to get the d's by themselves. How do you get rid of minus 7? Well, you'd add 7 to both sides. So what we're going to do is we're going to add 7 to both sides. Make sure you show that you've got a 0 pair on the right here. And so this is 12. That's funny. It's 12d, which is equal to 41 plus 7, which is 48. You now want to undo times by 12, so divide by 12 both sides, and you get d is equal to 48 divided by 12, which is 4. Once you have the answer, d equals 4. Like I said, it doesn't matter whether it's 4 equals d or d equals 4, same thing. So we know d is going to be worth 4. So 12 times 4 is 48. 48 take away 7 is 41. It works. And then put in your answer, and we're good to go. And then let's do the next one. I think you guys are hopefully getting more comfortable at this point. So I'm going to add a page here. Keep going. Great. So here's the next page, number 6. Number 6. We have 3 is equal to g over negative 4 minus 5. So here your goal is to get the variable term by itself. So you want to get this isolated. You know that we have to do the same thing to both sides of the equation. Now we've got it set up. I want to get rid of this minus 5. How do I get rid of minus 5? You'd add 5 not to one side but to both sides. This becomes a 0 pair on the right. You're left with 8 on the left. So 8 is equal to g over negative 4. You don't want to have the value of negative 1/4 g, or g over negative 4. What you want to have is the value of 1g. So how do you undo divide by negative 4? You just multiply by negative 4. And as long as you multiply both sides by negative 4, you're creating an equivalent equation. What's a negative 4 times a positive 8? Negative 32. And what is g over negative 4 times negative 4? Well, negative times negative is positive, and then what you end up with is 4g over 4, which is 1g. So this is going to be g is equal to negative 32, and there's your answer. If you wanted to write that out the other way, where you have the g on the left, you could, if those values are equivalent. How do you check it? Negative 32 divided by negative 4, what's that going to be? That's going to be positive 8. Is positive 8 divided by minus 5 equal to 3? Yes, it is. So now we've checked it, we know it works. Now I can plug it in. Negative 32, boom, done. And now the last problem we have, got some distribution again. So let's jump in there and do that. So this is 9 times the quantity of p minus 4 equals negative 18, and this is number 7. And like I said, I like to distribute first, so I would do 9 times p and 9 times negative 4, and that becomes 9p minus 36 is equal to negative 18. And then I would solve the way I normally would, which is to get the variable term by itself. How do you undo minus 36? You're going to add 36 to both sides, and that's going to cancel that out. So plus 36 not to one side but to both sides. This becomes a 0 pair. So you're left with 9p is now equal to negative 18 plus 36. Who wins? Positive by how much? 18. Now you want to get the p by itself. So how do you undo times by 9? You're going to divide by 9, not one side, but both sides, and you get the value that p is equal to 18 divided by 9, which is 2. Check it. P minus 4 is going to be negative 2. Negative 2 times 9 is negative 18. Bada bing, bada boom. There's your answer. If you wanted to do this that alternate way, you would just divide both sides by 9 first. 9 divided by 9 is 1, since it's just one set of p minus 4. In other words, p minus 4. And on the other side, you get negative 18 divided by 9, which is negative 2. And then how would you solve it from there? You want to get rid of the minus 4, so add 4 to both sides. And ultimately, you can see that the answer is, in fact, the very same p as 2. So choices you can make, pick the way that works best for you is fine. So the answer is p equals 2. All right. And that's how you do it. Hopefully that was comfortable for everybody.